Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about the rational root theorem, aka the rational zero theorem, or my personal favorite way to call this, P and Q factoring, which you'll see why I call it that in a minute. So real quick, before you watch this video, you need to be well versed in how to do synthetic division. If you don't know how to do that, I have a video. You can check the description for that. But assuming you know how to do synthetic division, the rational root theorem basically looks like this. I have some function, 5x cubed minus 4x plus 8, let's say, and I want to find the solutions for this function by setting it equal to 0 and solving. Now, obviously, we can't factor this. Maybe you think we can use quadratic formula, but you'd be wrong because this is x cubed, not x squared, so we can't do quadratic formula. So then we're stuck. Well, this is when the rational root theorem kicks into full gear, and here's what we do. The number in front of the x cubed, or whatever the highest power is called my q, and the last number, the constant, is called my p. And so the rational root theorem says that all of my real roots, as opposed to imaginary roots, which we will not talk about in this video, will be equal to p divided by q, where, watch this, all the factors of p, in this case, positive negative 8, positive negative 1, positive negative 4, and positive negative 2. That's all my factors of 8. Divided by all my possible factors of q, which in this case is only positive negative 5 and positive negative 1. And when I write it like this, I want you to realize that here are my possible roots. It might be positive 8 divided by positive 5. It could be negative 1 divided by positive 5. Could be negative 4 divided by positive 1. It can be any combination of these. But how do I know which one's right? Well, that is where the synthetic division comes in. So instead of doing it with this example, because this is a really complicated one, there's a lot of possibilities and the answer is not easy. Let's start off with a much easier one. F of x equals x cubed minus x squared minus 10x minus 8. And I want to find all the roots of this and all the zeros as much as possible. So first thing I do is I say q is equal to the invisible 1 in front of the x cubed and p equals 8. I don't care about the negative 8 because remember, when I do p divided by q, it's both the positive and the negative version of everything. So here it's going to be positive negative 8, positive negative 1, positive negative 4, and positive negative 2, divided by plus minus 1. That's the only factor of 1. And now for my synthetic division of x cubed minus x squared minus 10x minus 8, the setup is going to look like this. 1, negative 10, and negative 8. And now I just have to choose one of these values for my roots. I will try negative 2 first. Negative 2 divided by positive 1, I guess. But first I'll try negative 2, and I'm just going to do the synthetic division here, and my goal is to get a 0 at the end. If I get a 0, that means yes, negative 2 is a root or a 0. If not, it means I have to try again. And this is going to be a lot of trial and error. But let's do it. The 1 comes down, times negative 2. Negative 1 minus 2 is negative 3. Times negative 2 gives me positive 6. Negative 10 plus 6 is negative 4. Negative 4 times negative 2 is positive 8. And we get 0 as the result. So it looks like, yes, I got lucky. I chose negative 2. Sometimes we get lucky, sometimes we don't. If I was wrong, I'd just start over. But since I got it right, here's why this is great. First of all, it means that x equals negative 2 is one of my solutions. It also means that the remaining 1, negative 3, negative 4, I'm going to build my polynomial from that. And it's going to be 1x squared minus 3x minus 4. And that's what's left for my polynomial. And since it's squared, now I can factor this if I want. And I know how this factors. It's just x minus 4 times x plus 1. So the other right options were x equals positive 4 and negative 1. So then all of my zeros are 4, negative 1, and negative 2. And there we go. So in other words, yes, you can use the rational root theorem in combination with factoring. But remember where my original problem was with the x cubed? I can't factor that. So I had to use the rational root theorem to find the first one, which could have been -2 or +4 or -1 would have worked as well, any of those three. And so now let's do another example. Now let's say I have f of x equals 2x cubed plus 11x squared minus 7x minus 6. And again, I want all the zeros and the roots. So in the very least, I want you to pause the video and tell me what all the p over q solutions are. So go ahead, give it a try. Okay, so we know q is 2 and the p is 6. So that means p over q is going to be positive -6, positive -1, positive -3, and positive -2 divided by plus minus 2, and don't forget plus minus 1. Those are all my factors of 2. And so then when I set up my synthetic division based on the formula, it's going to be 2, 11, -7, and -6. And now I have quite a few options for me to try. My general recommendation, always try the easiest ones first. Like for instance, in the last one, I tried -2 first. Honestly, I should try something even easier than that, like positive or -1. Because usually your teacher's not trying to be mean. Usually it is the easier ones at first. So let's try -1 first. So pull down the 2. 2 times -1 is -2. 11 minus 2 is 9. -1 times 9 is -9. -7 minus 9 is -16. And honestly, as soon as I notice it's not going to work out, I can just stop here. So -1 didn't work. If I kept going, I would have gotten 16. 16 minus 6 is 10. Yeah, that's not 0. So then I got to try again. Oh well. Now I guess I'll try +1. So 2 times 1, 2, plus 11, 13, times 1, minus 7, 6, times 1, still 6. And yes, this time I got 0. So in other words, x equals +1 is one of my solutions. And for the other solutions, I just have to say I have 2x squared plus 13x plus 6. Now, maybe you know how to factor this. Maybe you don't. Maybe you even want to use quadratic formula. But just to prove that I can keep going with the rational root theorem, now I have to try another number. And I can start the p and q over with what I have right now. So in other words, positive, negative factors of 6 are 6, 1, 3, and 2. And in the denominator, it's actually the same thing as we had a minute ago with the p over q. And now I gotta try another one for x. By the way, it technically can be 1 again. Just because we got it once doesn't take it off the table. It could be 1 twice, could be 1 3 times. But I'll just tell you, 1 won't work. As a matter of fact, any positive number won't work. Because if I think about it, it's just going to keep building up as a positive number for the synthetic division. So I know it's got to be a negative number. I don't think -1 is going to work, because that's not going to add up to 0 at the end. So let me try -2 and hope for the best. Bring the 2 down. Times -2 is -4. That's going to be 9. 9 times -2 is -18. Yeah, that didn't work. Oh well. So let me try again. Maybe this time I'll choose -3 over 1, or just -3. So 2 times -3 is -6. 13 minus 6 is +7. Yeah, I see this is not going to work either. Which is fine. I just got to keep going, not give up. Next, maybe I'll try -6. Let's try that. So bring down the 2. Times -6 is -12. It's going to be 1 times -6. Yep, there we go. So x equals -6 is an answer. And then all that's left, 2 and the 1, means I have 2x plus 1. Set that equal to 0. Subtract 1 from both sides. 2x equals -1. And it looks like the last solution is -1/2. That's the only other one that would have worked for my synthetic division. So my answer is -6, +1, and -1/2. And there's my zeros. So hopefully you're starting to get the hang of it. We're just going to do one more today. I have f of x equals 12x cubed plus 56x squared plus 52x minus 24. This one is pretty tough. But one thing I can do immediately before I even set it equal to 0, it looks like everything here is divisible by not just 2, but actually everything's divisible by 4. So if I divide everything by 4, which I'm allowed to do, I get 3x cubed plus 14x squared plus 13x minus 6. And this just made the problem a whole lot easier. And so if you want to try the problem from here on your own, go ahead, pause the video, and unpause when you're ready to see the solution. Okay, so P over Q is going to be plus minus 6, plus minus 1, plus minus 3, and plus minus 2, divided by plus minus 3 and plus minus 1. And then for the synthetic division, the setup is 3, 14, 13, and negative 6. If I think to myself, just like the easy ones, positive, negative 1. Positive 1 definitely won't work because I just keep adding positive numbers. If I do the negative 1 in my head, 3, negative 3, 11, minus 13, negative 2. Yeah, negative 1 didn't work either. And I don't think many positive answers will work here because the positive is just going to get so big so fast. So I think the next logical choice is negative 2. So pull down the 3 times negative 2 is negative 6. That's going to be 8. Times negative 2 is negative 16, which is negative 3. Times negative 2, positive 6. And we'll get 0. So, yay, first try. So that means x equals negative 2 is my first solution. And now the remaining polynomial is going to be 3x squared plus 8x minus 3. Now, I'm pretty sure I know how to factor this from here, but I'd rather do the rational root theorem again and synthetic division just to prove the point. So I have to do my P over Q again. This time it is going to be easier because I'm left with plus minus 3 and plus minus 1 over plus minus 3 and plus minus 1. And for the synthetic division, 3, 8, negative 3. So I don't know. Let me try negative 3. Pull the 3 down. Times negative 3 is negative 9. 8 minus 9 is negative 1. Looks like I'm going to get it. And we get 0 again. Yay! So now I have x equals negative 2 and negative 3. And then the last one is just 3x minus 1. At this point, it's so easy, I can just solve it from here. 3x equals positive 1. And x equals 1/3. So then all of my solutions are negative 3, negative 2, and positive 1/3. And there we go. That's it. So I know this is pretty tough, but hopefully it makes sense now. And of course, if you do have any questions, please post them in the comments, and I'd be happy to answer them for you. So, have a great rest of your day, and as always, I will see you in the next video. Take care, and bye-bye.